Good evening, ladies and gentlemen. Mr. Kelum Manamendra-Arachchi, our distinguished speaker, distinguished invitees, trustees and members of the National Trust, and all others participating in the event this evening. I welcome you to the 142nd in the series of monthly lectures brought to you by the National Trust. I wish at the outset to express regret of the Trust on account of the gap in our lecture series since January. This has not been because we were having the show somewhere else, perhaps we might suspect Goldface, and encouraging the youngsters there, no, but for more mundane reasons, that the Trust has been in the present circumstances without a manager to take over the duties of looking after the Trust office, following the long line of diligent persons who have performed that task for more than a decade. With the assumption of duty of Zina Pereira, we hope indeed to continue these lectures without interruption and into the foreseeable future. The lecture today indeed concerns time in terms of the epochs or ice ages which are used to demarcate time periods of the Earth. The Pleistocene means the most recent of the glacial periods, which took over from the Pliocene, meaning the previous, more recent period. The demarcation of these two periods date back to 2.58 million years, and in turn, the Pleistocene seems to have handed the baton over to the present Holocene period some 12,000 years ago, and Holocene derives its name from new, even though it's been around for 12,000 years. I am sure the next epoch or period will be given an equally interesting name, but I'm not worrying too much about it, as some millions of years away is still there for that event to take place. And we have few other preoccupations in our minds in the next days, weeks, or months in Sri Lanka. The lecture today is Sri Lanka's Lost Animals, the Pleistocene period, and will be delivered by our distinguished lecturer, Mr. Kelum Manamendra-Arachchi. So welcome, sir. The panel for the National Trust comprises Professor Nimal De Silva, Honorary President, who will introduce our speaker presently. At the end of the lecture, a Q&A session will follow, which will be coordinated by Ms. Ayomi Ariviare, trustee, with the assistance of Dr. Nilan Kure, the Secretary General, who will take the place of any person who is not there serving the panel today because of various reasons, including power cuts. Behind the scene here, we have Mr. Jasit Herat, also trustee, who is looking after the technical end of this webinar. So we acknowledge his work with thanks. So please note, all of you present, that you should ask your questions on usually on the chat function, preferably. And so please write them down. We do request that you ask as many questions as you wish, but you must switch off at this point of time your audio and video function from the device that you are using to participate this evening, so that it may not disturb the lecture whilst it is in progress. So with those remarks, I now call upon Professor Nimal De Silva to introduce our distinguished speaker and wish you all an enjoyable and interesting evening. Thank you very much. Nimal?
Good evening, everybody. I'm very much pleased to introduce our learned speaker. He's one of Sri Lanka's foremost zoo archaeologists. It's a very specialized area. Mr. Kelum Manamendra-Arachchi has a research experience of over 30 years, focusing primarily on Sri Lanka's zoology, taxonomy, and paleontology. In 1980, he began his study of wildlife and zoology and entered the field of zoo archaeology in 1985. joining the Department of Archaeology, where he had the opportunity of working closely with Mr. P.H. Karunaratne, who was the country's foremost zoo archaeologist at that time. Later, he served as full-time research associate at the Wildlife Heritage Trust. He has led several teams of researchers on multiple projects, including taxonomic and ecological research focused on the amphibians, freshwater fish, and reptiles. In addition, Mr. Manamendra-Arachchi was also involved in and collaborated on a large range of other studies on the evolution and biography and biogeography and ecology of Sri Lanka's amphibian fauna. His two books, The Amphibian Fauna of Sri Lanka, 1995, then Sri Lankawe Ubejivin in 2007, are testimony to his encyclopedic grasp of Sri Lanka's herpetology. Since 2009, he is serving the Postgraduate Institute of Archaeology at the University of California as a research fellow, focusing primarily on zoo archaeology and Palestinian and Paleocenology. I will request our learned speaker to deliver his speech. Thank you.
Thank you very much, Dr. Nimal. This is a beautiful introduction. And I want to thank again Dr. Nilan Kure to invite to this lecture 2 weeks before, I think. Anyhow, my presentation is right. Today, actually, I'm going to discuss with you the fairly interesting subject, extinct animals. So I'm focusing especially Sri Lanka. This subject is actually, this is the subject is paleontology. We call paleontology. Paleontology means science of fossils, studying science of fossils. So paleontology is not a famous subject in Sri Lanka or universities. I don't know why. Anyhow, this is the paleontology is actually 3D subject, very interesting, and 3D subject, not a 2D subject, not flat. This is something interesting. Anyhow, the pioneer is actually in this subject, Dr. P.P. Dharanegala, first native director of Colombo National Museums. So, my talk is actually based on the P.P. Dharanegala's literature or publications and my experiences and my the recent collections of fossils. So the processing fossils, the processing period in Sri Lanka is our collection is mainly came from Ratnapura area, Ratnapura, Kuruvita, the Avisavella, Gatahatta, that marshy area. Then we call this is Ratnapura extinct fauna. Fauna means so in Sinhala it's a Satta Parapura, it's an animal group or something like that. The Ratnapura extinct fauna, the basic good word for this fauna. The Ratnapura extinct fauna actually, or extinct fauna in Sri Lanka is popularly known as Ratnapura fauna. So that's the real word for these animals, Ratnapura fauna. Range from 2.5 million years before present to about 11,800 years before present. So very 2.5 million to 11,800. That's the Pleistocene period. Then what is now we are in which epoch or period? So we are in Holocene. Actually, this is Holocene. After 11,800 or 7,000, now we are in Holocene epoch. Holocene epoch is the much interesting because this is modern man's period, Holocene. The reason for this is that most the Pleistocene fossils found in Sri Lanka are embedded in gem gravels or alluvial deposits of the Ratnapura area. You know, gem gravel means ilama. We call ilama. So the Pleistocene fossils found in Sri Lanka are embedded in the gem gravels or alluvial deposits or ilama of Ratnapura area. The gem pits of Ratnapura have yielded several fossils of an extinct animals which is considered to resemble closely the extinct Indian Shivalik fauna. So this is, I want to say that again, Ratnapura fauna and northern Indian Shivalik fauna is very close. Close mean species wise and biodiversity wise. Very close because here we found lion and India also found lion. Here Ratnapura is we found hippopotamus and the Shivalik beds also hippopotamus and rhinoceros is here and rhinoceros is Shivalik and something like that. Same fauna. Then these two fauna is actually very closely related. And extinct animals of Sri Lanka includes two species of terrapins. Terrapin means we call Ibu. And one crocodile. Two species of rhinoceros. Two species of rhinoceros. Rhinoceros, not dinosaurs. This is rhinoceros. We call in Sinhala Kangavena. Rhinoceros. And one hippopotamus, Gawara, and three elephants, and one lion, tiger, both lion and tigers, wild boar, Walura, and a bull, native bull, and wild buffaloes, including one or two unnamed two deers. Two deers mean like Titmu or something like that. Deers. So we have few carbon and thermoluminescent dates for these fauna. That is very important thing. Now we have an idea about how all these fossils. The radiocarbon dates are available by only for tiger fossils. We found tiger fossils from Matadumar in a cave. We dated by carbon 14. This range is 14,000 to 17,000 years before present period. 14,000 to 17,000. So that is tiger for tiger. And we found also rhinoceros teeth from Lunugala. Lunugala Adavatta is very close to Namanukula mountain range. Okay. And Dr. Mahan, dated by the thermoluminescent system. It is also a very reliable method. That rhino teeth, we have 80,000 years before present. The dates 80,000 years before present. So these three dates are actually very important to our explain our Ratnapura fauna. So Pleistocene period, you know, I think the Pleistocene period is a a penultimate period of geological periods in Sri Lanka. The penultimate is one before the last. Now we are in Holocene. This is the Holocene. This is Pleistocene. Pleistocene is divided to 4 sub epochs here, and 2.5 million to 11,700 or 11,800. This is the time period of Pleistocene. And now we are in Holocene. Pleistocene is the last glacial period. I think this is a very common theme with glacial periods. Sea level goes down some periods and again go up, and we call glacial and interglacial. In glacials, sea level go down, and interglacial sea level go up. So, and also this period is very important to human evolution. This is actually Pleistocene is human evolution, the period of human evolution, because our evolution, Homo sapiens, and Neanderthal mans, and Homo erectus, and Homo habilis also evolved in this period. Actually, we call Pleistocene. And also Pleistocene is a cooler period than, so now we are in Holocene, then very cooler. And also biodiversity is very rich, and so many flowering plants and sea fishes, coral reefs, also different biomes. Biome means different vegetation and climatic zones, and Alps and tundra, and also Arctic and savanna, something like that, different many things. Okay, so Pleistocene is actually biodiversity high, evolution is very nicely and very rapidly, things are something like that, very rich period. Okay, this is now we are in the Holocene. Holocene is modern man's period. It's our period. Modern man's period is we start agriculture, plant and animal domestication, deforestation, destruction. Our destruction, that is urbanization, unnecessary gases we release to air, and damage in ozone layer, and water and air pollution, something like that. Unnecessary things we are doing to our habitats and our environment. So this is Holocene, and now we are in Holocene. Anyhow, so the last 8, especially 8 decades, we found many Pleistocene fossils from this type of gem pits. This gem pit is actually Kurvita Edandavela. This is a paddy-filled gem pit, a very deep gem pit, and this is fairly shallow gem pits. This is Ahaliagoda, and you know, this is also gem mining. This is we call Adinapatal. This is a surface. There are certain surface gems. So gem miners, they are the people who gave us the Pleistocene fossils to study. And Paul Edward Peters is the pioneer of or founder of paleontological studies in Sri Lanka, and he described many species and published about unbelievable amount of research papers and few books on fossils. And also he collected many things regarding to, paleontology, not only the Pleistocene, Miocene, the Jurassic, so many fossils collected. P.P. Dharnegala. P.P. Dharnegala actually, I want to say little words to Dr. Dharnegala. Dr. Paul Edward Pires Dharnegala was an all-rounder, actually, with most of the attributes required of an ideal Renaissance man. We call Renaissance man. Then he very, very keen naturalist and scholar, painter, athlete, explorer of international caliber. So I think I know you know very well Dr. P.P. Dharnegala. He received his first appointment in Sri Lanka on June 1925 as a second assistant marine biologist. Very interesting chair, second marine biologist. Dharnegala was appointed the director of Colombo Museum on 1939. 1939. So, and the number of his books and research papers exceeded 420 and appeared in the National Museum Bulletin Spolia Siranica. So, you like to read his literature, and Spolia is his famous journal, the Colombo National Museum Journal, and he published, I think, 99% of his literature is the papers in Spolia Siranica. So now I want to show you his artworks related to today our discussion. I will show you some artworks of Dr. Dr. P.P. Dharnegala. And his birth year is 1900 and 73 years. But this is interesting thing. 27 years old P.P. Dharnegala. 27 years old. Back from Yala with leopard and other cats' skins. Okay, and this is for Colombo National Museum, this taxidermy section. He collected the Yala National Park, and this is the Dharnegala's lab. Now is this room actually conference room in National Museum. Those days, this space is actually Dharnegala's space for studying mainly fossils. And this is in Africa, 1947, with California University explorers, especially paleontologist. He is collecting fossils, hippopotamus, tortoises, and human, and he described many species after this expedition. So this is Dharnegala. 48 years old Dharnegala. This is his in field. Here, actually, really interesting. 1962 drawing. Here, the Gawa and Balangoda man. The Balangoda man hunting a Gawa. What do you think about this? Huh? Prehistoric life. Reconstruction sketch. And this is watercolor. Wild boars with python. white ghost and python. This is watercolor. He's good, he actually the Nicholas watercolor paintings are very beautiful. They're very and this is largest sea turtle. We call leathery turtle, Daracus bava. Fairly rare now. This is also watercolor. And this is Lema pila, we call in English Foster's cat snake, Boiga fosteri, Lema pila. Lema pila is not deadly, but venomous, not deadly. And this is the Mahaveli species. This is called Gadea in Sinhala, scientifically Labiophysarii. And very accurate scale drawings. He counted all of scales and fin rays and everything. What is this? This is Rukkatana carving. Rukkatana, yeah. The wood is Rukkatana. This is Balangoda man. Balangoda man's carving by Darniyagala. And I want to tell you the face is physical anthropologically accurate. I mean, he included all characters of Balangoda man's face. Here, the forehead means eyebrows, and this is forehead, Nalala, and very prominent Balangoda man's forehead. And here he carved very nicely, beautiful forehead. And the and this width is wider than us. I mean, Sinhalese and Tamils, wider than us. And nose is very short here, and nose is wide. And cheekbones are prominent here. Cheekbones are very prominent. And distance from lower nasal to upper lip fairly high than us. And chin is prominent. And also lower jaws, mandibles are heavy looking. That's why I told you he carved very carefully with all physical anthropological characters. Now this carving is a property of British Museum of Natural History because those days Dr. P.P. Darnigala donated this beautiful object, British Museum. And this is second one, an extinct elephant. Extinct elephant. I think this is scientifically heads up. This is Paleoloxodon nomadicus, most probably. This is the length is about 2 feet and height is nearly 10 inches. Now this is at Eknadwala Puruvita. Very beautiful art piece. Very nice. I like very much this. And what is this? Head of hippopotamus. He, after his African expedition, he named fossil hippopotamus to who? To Leakey family. Leakey family means in England, the physical anthropological family. The Louis Leakey. The name is Hippolycius Leakey, Hippolycius gogops, African extinct hippopotamus. This is actually very, very small. This is nearly the length is uh, about 8 inches, small object. So how much? So this is Delanegala's something paleontological and zoological, everything here, painting and objects. And finally, this is dark as Bava or leathery turtle, bronze. This is bronze. Okay. So what do you think about now, Dr. Delnegal? His talents. Right. Okay. Delnegal's research, paleontological research in Sri Lanka, he uh, in his time period, he published 32 research papers on prehistory, and our subjects, paleontology, fossils, about 72 research papers, international and 32 research. Yeah, this book, he's published in 1958, The Pleistocene of Ceylon, Pleistocene Studies, including all of things, everything. Very good, actually. This is marvelous, fantastic book. The Pleistocene of Ceylon. And extinct animals of Sri Lanka now. We are main discussion, the extinct animals. You know, in Sri Lanka today we have island, 3 tortoises and terrapins. 3 tortoises and terrapins. This is we call in English black turtle, but this is not a sea animal. This is freshwater. So it's in English we call black turtle, Indian black turtle. Scientifically, Melonocalis trijuga. We have only 3 tortoises and terrapins. And this is, we call in Sinhala Kiriba, Sri Lanka soft shell terrapin. Soft shell means the surface. The black turtle's shell is very hard. This is very hard because this is the black cover is keratin and the inside the bone. And here, soft skin here, but inside is actually covered by bones. But surface, normally surface is very soft because very thin, covered by very thin soft skin. So then we call soft shell terrapin. And scientifically, Lacemys sinensis. And third one, star tortoise. And these two in wide distributed, dry zone and wet zone, both lowlands and rivers, ponds, lakes, everywhere, in freshwater or brackish water. But this is restricted to Sri Lanka dry zone, especially Anuradhapura, Columnar, Varadikavarantia, something like that, dry areas. And we call star tortoise in English and Tarukaiba, Geocalion elegans. So these are extant species. Now we can see in Sri Lanka this. But in Pleistocene, we found 2 species of extinct terrapins. This is the fossil in on your left side, and this is Galliba. This fossil name Darniagala Geomida trijuga singhalaya. Geomyda trijuga singalea. Geomyda is generic name, trijuga is species name, and singalea is subspecies name. This subspecies. This subspecies is restricted to Sri Lanka, especially Pleistocene. Now, this giant species is extinct. Okay, uh, the Geomyda trijuga singalea is very close to this Gallimba, present Gallimba, but size is this is bigger than Gallimba, nearly 1.5 times large. Okay, and here this the fossil is represents this part here. Okay, and this is we call carapace, and in scientific this is carapace. Uh, the surface underside is plasteron, and this is represent carapace. I found about the Dernigal discovered about five five fossils of this terrapin, and that's after few about 10 or 15 years before, I found about 2 or 3 another fossils of Geomyda trijuga singalea extinct terrapin. This is the native and Pleistocene terrapin, now extinct. Now we have another species here. And this is also another interesting fossil animal. And on your left side, the fossil, and this is Trionyx punctata singalea. They are going to describe this is Trionyx punctata singalea. Morphologically very close to Kiriba. But this is not backbone, back area. This is under area in plasteron. The part of plasteron, this is completely fossilized part of a plasteron underside. And here recent Kiriba and recent Kiriba and extinct Kiriba very close. But there are many differences morphologically and especially morphologically. And also now, you know very well, in Sri Lanka we have two crocodiles. Upper one is saltwater, lower one is mugger. Actually, I think the largest reptiles in Sri Lanka, these two. Saltwater is normally the coastal bills species, and mugger is normally freshwater species. Only 2 species of crocodiles now extant. But Dernigal discovered this tooth from Ravipura Genpit. He described this new species as a new species, Crocodilus singaleus. Crocodilus singaleus is actually not a extinct species. This is extinct species. Now I'll show you again the saltwater crocodile is Crocodilus porosus, and mugger is Crocodilus palosus, and this extinct one, Crocodilus singaleus. But we have only 2 fossilized teeth for this species. Okay, anyhow, the Dernigal is the Dernigal described as a new species with so many external morphological characters used by this fossilized tooth. So the second tooth I found 5 years before. This is it was very complete. And then this, so I think both teeth belongs to crocodilus singularis. And do you know this animal? Can you guess what is this animal? Not a dog, not an area or jackal, not a wolf. This is, in English, the common name is dhole, D-H-O-L-E, dhole. And other English names are Asian wild dog, and Asiatic wild dog, Indian wild dog, whistling dog, red dog, mountain wolf. But the English name is mountain wolf, but this is not real wolf. Wolf's zoological name is Canis lupus. Here, the zoological name is Coon alpinus. This is a different animal, and this is dhole. Dhole is actually a really interesting animal. Dhole is a canid. Canid means carnivore animal, native to Central, Southeast, and South and East Asia. Now you can see the distribution pattern in red patches. The dhole is highly social animal living in large clans without rigid dominance hierarchies and containing multiple breeding females. Okay. And also, such clans usually consist of about 12 individuals, but groups of over 40 are known, and it is a diurnal pack hunter to preferentially largest, medium, and large size sambas and deers. Okay. In 1958, here, this is the important thing. In 1958, Dernier discovered the canine tooth from Gonapitia near Kuruvita from a gem tooth, this canine tooth. And finally, he described this tooth as an extinct dhole. He named, Dernier named, Coon Javanicus Sinhaleus. Then, Pleistocene, actually, the dhole's distribution is wider than today. I think that's the reason we found this specimen from Gempit. This is Coon lower canine tooth. Really, really interesting thing. The Coon is, we call hunting dog. It's a hunting dog, not the African hunting dog. African hunting dog is a different, zoologically different animal. This is Coon, very close to our jackal, but different genera, two different genera. This is the skull of Coon, the oval-shaped skull, and see the teeth are very, very sharp and very pointed. And Asian elephants. Actually, I like very much elephant skulls, elephant fossils. The Asian elephant is the only living species of the genus Elephas. You know our Sri Lanka, the species is Elephas maximus. And is distributed throughout the Indian region, elephants. I mean Elephas genus. P.P. Darniyagala, Hobart, Hooger, Ames, Foster Cooper, and Lydecker discovered and described so many fossilized elephant remains from whole of Asian region. The large amount of fossils discovered these workers, and Asian elephants now today external morphologically and uh, DNA studies. This recognize 3 subspecies, right? 3 subspecies. Interesting thing is Elephas maximus subspecies restricted to this small island, Sri Lanka. Elephas maximus. Elephas maximus indicus, India, the mainland actually India, and Elephas maximus Sumatra is Sumatra. But important and very interesting thing is Elephas maximus. The subspecies today restricted to our island. Okay, right. This is from this specimen from Ratnapura area, in Kuruvita. Actually, 3 species of prehistoric elephants now extinct are known from Ratnapura fossil beds. One, Elephas hysuticus, now extinct. Elephas namadicus, also extinct. This is namadicus, and this is hysuticus. Now you can see notice this Elephas namadicus, the forehead. So the extant species forehead is actually very sloped. This is a huge ridges here, or something like that. This is Elephas namadicus, and this is hysuticus. Hysuticus, here the huge groove is here. Now you can see here groove, and this is for fossil of molar, part of a molar tooth. Elephas hysuticus. Elephas hysuticus and namadicus both extinct. And what might have been a progenitor or ancestor of the Asian elephant. Ancestor of Asian elephant. Elephas maximus singhaleus, which differed from today's elephants by being smaller and having slightly different tooth shape. So this is progenitor of Asian elephants. Okay, this subspecies also found Ratnapura beds. Jalanigala and other workers agree this is progenitor of Asian elephant. Progenitor means ancestor. So on your left tooth, actually donated by Dr. Siram Daniel to my personal collection, and also some with some tusk fragments. And here, the complete molar tooth of Elephas maximus singhaleus from Ratnapura, Yempit. See we call this surface is grinding surface or occlusal surface, grinding surface. And you can see the black ridges here. Okay, here, black ridges. We call these lamellae. Lamellae mean enamel ridges here. innermal ridges bound with actually this is cement. Okay, this is very heavy, about 6 or 10 kilograms, and black area is enamel and brown area is cement. And this is the lateral view, and you can see the very clearly here lamellae. See, lamellae 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 to 15 lamellae is represent this maximum signal. Anyhow, okay, rhinoceros. Rhinoceros. What do you think about rhinoceros? So, 5 living species, 5 living species, rhinoceros. 3 is restricted to Asia, 2 is African continent. And the interesting thing is here, today's distribution of rhinoceros family, and brown area represent here white rhino, 2 populations, and purple color black rhinos, very patchy distribution, most probably urbanization, black rhino, and third one, Indian rhino is represent the red, and Javan rhino, blue, and Sumatra rhino is green. But, so this is white rhino Africa, black rhino also Africa, Indian rhino, this is Javan rhino, in captive, and in captive Sumatran rhino. Sumatran rhino, see the two horns, but Javan rhino only 1, Indian rhino only 1, black rhino 2, white rhino also 2. Right? And also, we have 2 species of rhinoceros, to mean 2 species, the fossil rhinos. Rhinoceros singularis and Rhinoceros mangavenus. 2 species of rhinoceros are known from the Ratnapura beds, both of which seem to have been around at the same time. Rhinoceros singularis and Rhinoceros mangavenus. Both are one-horn species and distinguished by differences in their especially upper molar teeth. Now I'll show you the difference of 2 species. Actually, this is my idea. My feeling is the Rhinoceros mangavenus, the lower one, could be same species as living Javan Indian rhino, sorry, not Indian rhino, and also Singularis could be same as living Javan rhino. Okay, but the irregular described as a 2 species, not related to Indian and Javan species. Here, this is Singularis. Singularis teeth, so size is very small. Size is very small, and height is also less than other species. Okay, these are front teeth or incisors. Kruntaka. This is upper molar. Upper molar. Now you can see here the height of the tooth, right? Height is very very low, and the occlusal pattern also different. This is rhinoceros singaius. The Dr. Mohan dated this is 80,000. The era is 20,000. And this is also rhinoceros singaius. See the height. And this is lower jaw of rhinoceros singaius. And lower molars also low crown. And this is reconstruction painting, my painting. And this is rhinoceros kangaroo, a larger one. See the height of upper molars, huge size. And this is very close, morphologically close to Indian rhino. And this one, sorry, and this one is very close to living Javan rhino. But can't say we have to do some research, especially molecular research for this problem. And this is rhinoceros kangaroo, bigger. And two, we found many fossils of wild boars. Our extinct wild boar is actually smaller than living wild boars. And also the head is laterally flattened and head is actually compressed. Size is small. And this is the extinct wild boar, the two lower molar teeth highly fossilized. Highly fossilized from also Ratnapura gem pits. This is the reconstruction of my Susingareus. And hippopotamus, hippopotamus are now restricted to African mainland, but in processing is a widely distributed species, probably in Asia and other Asian countries. These are recent African. This is actually the skull of hippopotamus. Now you can see here, especially this is these four. 1, 2, 3, and 4 here. Fourth one. These are incisors, lower incisors, and these two canines. And this is 1, 2, 3, 4, also incisors, and this is upper canine. These are premolars and 3 molars. Especially the front teeth are huge. Hippopotamus front teeth. The hippopotamus scientific name, the large ones, scientific name is Hippopotamus amphibius. Amphibious means the meaning is the both aquatic and terrestrial life. Genus is Hippopotamus. This is extant species, right? Now Africa is actually hippopotamus country. Two different hippos there, and one is Kur hippo and a dwarf one, and the one bigger one, right? And here, our extinct one. Then included this species to really interesting genus, Hexaprotodon, right? Not hippopotamus, Hexaprotodon. Hexaprotodon also hippopotamus, but two different genera. Can you break this word here? Hexa. What is the meaning of hexa? Hexa is 6. Proto. Proto means early or front meanings. proto, and don is teeth, right? And our one has actually 1, 2, 3, 4, 5, 6. 6 incisors. Not 4, not 4, 6. The number is higher than the African one. Okay? 6 incisors. Hexa means 6. Proto means front. Dot that or teeth. Right? Istara that higher. The front 60. Hexa proto. Very beautiful generic name. And canines here. And upper canine, lower canine. This is our extinct species. My reconstruction drawing, and also here. These are hippopotamus fossils found from the Gatahatha to Ratnapura, the flat land, right? All from dead bits. This is a lower canine. This is premolar, highly fossilized. Molar tooth of hippopotamus. See the cusps, very rounded, blunt cusps. Is the main character of hippopotamus molars. And this is also molar tooth. Molar. And so we found a tooth, this highly fossilized tooth. This is very close to dry zone spotted deer, and also close to morphologically barking deer or hog barking deer, or actually barking deer. In Sinhala we call Valimua or Olumua. Very tiny tooth, tiny molar tooth. Then they're going to decide this is a different new species, Mua Sinhalaya. Okay, this is extinct now. And Gava, finally, Gava is the largest bull in the world, actually. The Bos Gaurus. This is a male. See the muscular hump here, right? Muscular hump and the prominent forehead and very thick horn course and muscular body. So here to here, the hoof to shoulder, right? Height is 2.2 meters. 2.2 meters, right? 2.2 meters. Anyhow, the Gavas are now still in Western Ghats rainforest. Males are fairly aggressive, and sometimes females also. And what is? Oh, yes. So this is Sri Lanka Gava fossils. This is represent the forearm, front arm, lower area. This is upper molar tooth. Jarnigala describe this Gava is restricted to Sri Lanka, but now extinct. Not very close to the Indian species. What do you think? This is the horn mean the bony part of the Gava, and neck vertebra. Here the back skull, Sinhaleus, and Sri Lankan one, right? Sri Lankan Gavas, the base of horns are very wide, base of horns, and immediately curve inside, right? This is the main difference of two species. Size is same, huge, and here the hump, long hump, and muscular body, and lower part of the limbs white in color. The body is bluish black, and the forehead hair normally golden color. This is Sri Lankan gaur. And one wild cattle fossil discovered Jarniagala unearthed from uh, Puramaru area, a part of a horn. Horn means this is also body part. Uh, Jarniagala gave a very nice name, Gona Singhalea, right? New genus, new species. New genus is Gona Singhalea because size is very small, right? Size is very small mean the shoulder height is normally less than 3 feet. So Batu Harake, we call Batu Harak. Anyhow, this is a native cattle in Pleistocene period, Sri Lanka. But now we have no cattle. All cattle are actually for foreign, and also this is cattle. And one lion tooth, fossilized tooth, also found. This is the tooth, beautifully fossilized, very nice, and also very less damages. And this is found from 19 feet below in 1936, Kuruvita, Ratnapura. Kuruvita, Ratnapura. Panthera leosingaleus. Panthera leosingaleus. The one of largest cat family member. And also we found tiger. In Sinhala we call Viagra, Panthera tigris, and very clear two fossils. One is molar tooth, other one is phalanx, middle phalanx. Middle phalanx. This is unearthed from Kuruvita Baradomalena, and this is from a gem pit near Kuruvita. So this is tiger. Then we had both large cat family members, tiger and lion. So we this Baradomalena specimen is we dated. This is this phalanx is actually 13, 14, 14,000 years before present. Most probably this is the Balangoda man's collection. And these are these specimens. Also Balangoda around Bartomelena and Bartomelena. This is Professor Gami Adhikari's excavation. Alavala Podgulena and Fahill Cave also found tiger fossils. Right. My lecture is over. Thank you very much. ladies and gentlemen. Thank you very much.
Hello. Ayumi, would you start the Q&A? Thank you very much, Mr. Kelum. Manamendra-Arachchi, absorbing lecture. Didn't know, but we want to start the question time. Ayumi Aluari would be in, I saw her coming in.
So, Mr.
So
Vikram, so Dr. Vikramaga, yeah, the volume is very low.
very low. Okay. Ayumi, are you there?
Yes, I am here.
Okay. All right. Okay. So if there are questions, would you start? Can I be heard? I
Yes,
don't know
yes,
if
you can be heard. We haven't got any questions on the chat group. If any member or participant has any question, it can be raised on the chat group.
Q&A or the Q&A, no? Yeah. I said chat group or I don't see. So
We don't have any queries on the chat group or on the Q&A space.
may I just ask a question, Mr. Kelum? How is it that this concentration of findings were only in Ratnapura? It's is there because of the gem pits? Is it because the
Dr. Vikramaga,
discovery was entirely due to the gem pits?
no. So, Dr. Vikramaga, yeah, the sound is.
No, I'm Mr.
Can't hear.
Vikramanth. So, okay, thank you, Vikramanth. Would be easier. So I'm saying why all this collection of fossils have been found in Ratnapura. It's not to say that these ancient animals were located only there. Sri Lanka has.
No, excuse me, Dr. Vikramaga, though, I can't hear you.
Okay. Can you Ayumi, can you take that question and ask? Maybe.
Yeah.
Could you repeat the question again, please?
Yeah, the
Yeah,
question
please.
is that why the fossils were found only in Ratnapura. Is that entirely due to the gem pits and there would
Yeah.
be fossils elsewhere?
No, I think the gem pit environment and water, mud, and so many the habitat is very good to preserve the animal parts. That's the reason. The
Okay.
preserve in Ratnapur area most of fossils. So the gem pit microhabitat, the water qualities and mud and sand, everything is very positive to fossilized animal part.
Interesting.
Do you agree?
No, I must agree because I know nothing about this. But
Because-
just one other thing. If I'm speaking loud enough, do forgive me. But there is no findings anywhere else other than Ratnapura. I mean.
No, that white color fossils, the rhino teeth. So I found from the Adavatta. Adavatta is Namanukul area. And one rhinoceros tooth collected from the surface of Bundal area, the Professor Gamini Adhikari. Actually, sometimes rarely found. Other areas.
Thank you. There are a few other questions. One is, how do you identify as teeth or bone any of the extinct animals without the animals being around?
Right. No, actually, so we have to study about extant animals. Then we can grasp an idea about how what we can do now. We can I'm saying. So we have 5 species of rhinoceros, and we found that from the bit from the bit of the tooth. Now I have the tooth. I want to compare with those 5 species and related living species and related extinct species. Then how can so then I can grasp idea about what is this and which group, which genus, which species, which subspecies, something like that. So the main thing is compare with recent fauna, recent teeth, bones, skulls, and things. The comparison is very important, and your background knowledge also very important to identify fossils.
Thank you. How do they become extinct? How do they become extinct? What is the cause of extinction?
The paleontologists, zooarchaeologists, biologists, ecologists publish many literature about cause of extinction, but exactly can't say the reason or reasons. Most probably the human interaction, main hunting, and also sometimes climatic conditions, and invasive. I mean invasive mean the aggressive species invade some habitats, something like that reasons, and also diseases, most probably. But there are many models, theories, concepts. Can't say very
Okay.
exactly. We can't
Thank you.
say.
If Sri Lanka had lions and tigers, how long ago was it?
Most probably, actually, my idea is Chinese, like the tiger is 100,000 or 150,000 before live here. And tiger, we have dates, the clear dates and exactly dates, 14,000 to 17,000 period. But lion more older than tiger, because lions habitat is dry savanna habitats. Now we have dry savanna habitats in Sri Lanka. Actually, most probably the lions 1,000, the 100,000 or 150,000 years old before.
Another question, why did these extinct species have such powerful jaws?
Why ask them that type of question? Powerful jaws mean the extinct lions also powerful jaws. And extinct tiger also have powerful jaws, and saber-tooth also have powerful jaws. And the reason tiger, lion, the hyenas have also powerful jaws. Most of carnivores, especially cat family, jaws are very powerful. They are not.
Was there a land link between Sri Lanka and India that resulted in the animal migration during this period?
Definitely. Correct. Yes.
That is the last of the questions that have been raised on the chat group. Thank you. Thank you for those responses.
Ayami, can I ask another question?
Please go ahead.
I couldn't understand your answer to my question as to how you decide that these little bits of bone that you find are the tooth or the whatever it is of a particular animal which you haven't seen and which is not around now. I couldn't understand your answer.
Yeah. So thing is, paleontologists are normally fossils compare with recent animals. So recent mean the example is the lion, tiger, hyena, something like that, the recent animals. And the paleontologist also, his fossil compare with extinct animals, teeth and bones. And then he can understand finally his fossil to goes which group or which family, which genus, something like that. The comparison study is very important to paleontologists to understand, especially identification. So if you can come to my lab, PGIGR, one day I will show you practically how can do that thing. I'm inviting you.
Thank you. There is, I think, Apsara, you have raised your hand. Would you like to raise your question? If you unmute yourself and you can ask the question.
Thank you so much. Am I audible?
Yes, you are.
First of all, thank you so much for the intriguing lecture, Mr. Kelum. I have two questions. My first question is, are there any microfossil records that associated with the Pleistocene megafauna? And the second question is, what are the in situ conservation methods that we can use while collecting these kind of fossil samples?
The first question is the microfauna. Yes, actually, one paper, a foreign scientist described pollen from gem pits. It's a palynological side, pollens of gem pits, and also some plant fossils, but plant fossils are not micro, that the pollen one is important. And what is the second question you? Hello?
My second question is the in situ conservation methods that we can use while collecting these kind of fossil samples, what we can use.
In situ collection, in situ conservation things.
Yeah, in situ conservation methods.
In situ conservation means you want to protect fossils.
Yeah.
Any program? No. We have no any program, but Ministry of Environment and actually conducted few workshops and seminars to gem miners to about what they can do for fossils, something like that, and don't break fossils and don't throw fossils and don't sell to foreigners, something like that things. But no any other in situ conservation programs here. Sorry.
Thank you so much. Thank you for much your answer.
Thank you.
Any other questions, Bhargavi?
No, there are no other questions.
Okay, if there's no other questions, my duty is to thank you, Mr. Kelum, Manamendra-Arachchi, for this really greatly revealing lecture. Quite a lot of this is completely new to most people, certainly to me, and that we had these large numbers of extinct animals who were in Sri Lanka. The one question that was asked was that did they migrate into Sri Lanka or out of Sri Lanka? Was in the land bridge, time of the land bridge, probably into Sri Lanka. Is it what you said?
Yeah, actually, I think some species migrated, especially large mammals, but small crabs and snakes and frogs are not migrated to in this land bridge, but large mammals, especially tiger, elephants, lion, hippopotamus are migrated here and India and mainland and Burma side and also. Because the reason is the Hexapododon genus, the found all of Asian region, Java, Sumatra, Borneo, Burma, Sri Lanka, and India, the whole area. Then the animals are migrated, definitely.
Thank you. So once again, appreciation for your lecture and making the time to give this lecture. It will be in our website to be viewed for a long period of time. So thank you very much again, and to all of those people who came in and listened to this wonderful lecture. Thank you to them for raising the questions. And if you've got anything else to ask, please write to us and we'll pass on your questions to Mr. Kelum Manamendra-Arachchi. So with that, we close the session for this evening and wish you all good night. Thank you.
So good night. Thank you.